Hi and welcome back. This section is on compression, deduplication and compaction, and there will be a small demo on every topic. We'll first start with compression, which is literally also the first thing that is done if you would enable compression, deduplication and compaction. After the compression demo, we will talk about compaction, which could work very well together with compression if needed. And finally, we will have a look at deduplication, concluded with a demo as well. Compression can be run inline or post-process and includes the capability to compress existing data. Compressing existing data is best not done during peak hours because it will generate a lot of I/O, obviously. Also, the more volumes you compress simultaneously, the bigger the impact on performance. So compressing data can either be done when data enters memory or when data is already on disk. Next to either inline or post-process, there is also a difference in the amount of data that is compressed. What I mean by that is that ONTAP works or Waffle works with compression groups. That means there are two sizes of block groups, or as NetApp calls it, compression groups. So you can compress groups of 8 kilobytes or groups of 32 kilobytes. Compressing groups of 8K is called adaptive compression. Compressing groups of 32 kilobytes is called secondary compression. There is an important note about this. You cannot enable both adaptive and secondary at the same time. And if you want to change from adaptive to secondary, or the other way around, you will first have to undo all compression that has been done so far and start all over again. Inline adaptive compression means that 8 kilobytes are viewed and ONTAP checks what the compression will bring. The rule is that if an 8K block cannot be compressed for half or more, then compression will not take place. So adaptive compression means that 8K blocks will be compressed for 50% or more, or the blocks will not be compressed at all. For secondary compression, ONTAP works with 32 kilobyte groups, and the minimum compression rate should be 25% or more. So if a secondary compression cannot compress 32K blocks to 8 kilobytes or more, then compression will not take place. The rule of thumb is that if your main goal is maximum compression, then it is advised to use secondary compression. Inline adaptive compression works nicely in cooperation with compaction, as we will see later, but doesn't give you the best compression ratio. Enabling inline compression means that you either compress 8K groups or 32K groups in memory. Compressing in memory may reduce the number of I/Os, and of course it will save space if possible. So inline adaptive compression will calculate whether compression can compress for more than 50%. So an 8K block will minimally compress to 4K or more. Secondary compression will calculate whether compression will compress for 25% or more. So a 32K block will minimally compress to 24 kilobytes. So in summary, compression can be true or false. When compression is set to true, then post-process compression is on by default, and it can be scheduled. And you can either have adaptive or secondary, and inline or post-process. Now, the demo on compression is pretty straightforward. I have two aggregates, X data and Y data, and I have two volumes, XVol and YVol, in the respective aggregates. Then, from two Linux terminals, I will create some files in both volumes at the same time. The X volume will be compressed with secondary compression, so 32 kilobytes compression groups, and the Y volume will get no compression. Then we'll check the outcome after the I/O is done. The second time around we'll have secondary compression on the XVol again, but now the YVol will be compressed with inline adaptive compression. And we will run the I/O again and check the outcome. Now in the Linux terminals, let's first cd to the directories that will hold the respective volumes, so the XVol and the YVol. So we go to the XVol on Linux 1 and we go to the YVol on Linux 2. And when we look at the file system space, we see we've got about 2 gigabytes of available space in both volumes. Then we turn on efficiency on the X volume. So we do not turn it on the Y volume, so just the X volume. And after we've done that, we will enable compression. So we say compression is true, the compression type will be secondary, and it's going to be inline. So we run inline secondary compression on the first volume. So all we have to do now is we go to the Linux terminals and we will run a little script that I prepared that will generate 1K, 2K and 32 kilobyte files in both volumes at the same time. And we see the time difference is negligible, so we have completed in about 36 seconds. And now we check the efficiency of both aggregates. So we run aggregate show efficiency and we see that we have 2.46 to 1 compression ratio, or it says storage efficiency ratio, which is a combination of compression and deduplication. But since we've only enabled compression, we could say that this is really a compression ratio. And we also check the logical space used versus the physical space used. So what does the client see and what is really stored? And we see that the logical space used is 44 megabytes in both cases, but the physical space used in X data is a lot less than in Y data because of the compression, obviously. And the volume compression saved is 26 megabytes versus 0. And again, 2.5 to 1 is the compression saved ratio. So that completes the first test. Now in the next instance, we will enable compression on both volumes. The first one will still have secondary compression, and the second one will have inline adaptive compression. And we reverse the situation, so we start from scratch with 2 blank volumes, 2 gigabytes of space available, and we enable efficiency on X volume, and we enable efficiency on the Y volume as well. So both volumes have efficiency enabled, and we set secondary inline compression to the X volume, and as we agreed, we will set inline adaptive compression to the Y volume. Now we run the same I/O test again. So you run time I/O and it takes 38 seconds. So there's no real time difference between the two compression types. But now we see that we have 2.46 versus 1.51. So obviously the secondary compression type is compressing a lot better than the inline adaptive compression. So as we discussed in the slides, if you want to have better compression, you should go for secondary compression in general. Depends a little bit on the files that you save, but usually secondary compression will give you better compression. Then we check the efficiency of the logical and physical space used, and we see that both have a logical space usage of 44 megabytes, and as we would expect, the physical space used by secondary compression is less than the physical space used by inline adaptive compression. So this completes the second test, and we're done. So let's move on to compaction.